But the question with the law of sines is, I'm only going to use two of these. Oh, look out. I'm only going to use two of these at a time. So I might use the first and the second one. Or I might use the first and the third one. Okay? Once I've established I'm using the law of sines, I got to figure out which one I'm using. Alright, so let's bring this slide up here. And we said that this was going to be angle, angle, side. So angle, angle, side. And we knew that was a law of sines situation. Well, it looks like I know angle B, and I know side B, and I know angle C. So of that law of sines, I think I'm going to use this. Little b divided by sine of b equals little c divided by sine of c. That's the piece of the law of sines that I'm going to use. Little b is 15 divided by sine of b. Sine of b, well, angle b was 25, equals little c, which was, oh, I don't know that, divided by sine of 107. Alright, I'm going to multiply both sides by sine of 107. Why does that work? Cross multiplication would work beautifully. You can cross multiply if you want. It's going to take you an extra step. If I remember, sine of 107 is just a number, right? I can punch that into my calculator. It'll spit back some decimal or some value. That's just a number, so I can multiply both sides by it. That will leave me with just c. So in your calculator, please type in sine of 107 times 15 divided by the sine of 25, making sure that you're in degree mode. What do you get for c? 33.9.
I got 0.3.
So I know that if I'm looking for side A, I'm going to use little a divided by sine of A equals, I'm going to use b and little b again, big B and little b, so I'll take little b divided by sine of b. Right, since that's what I already know, it's what I was given. So I'm going to plug everything in. Little a divided by sine of, oh, what is angle A? 48, good. So that's 48 degrees. Lesser known band, but almost as good as 98 degrees. And B we said was 15 divided by the sine of 25. So once again, we're going to approach it the same way. Multiply by sine of 48. And multiply by sine of 48. These cancel out on the left, and what do I get for little a?
26.4.
26.4?
There we go. Okay. Yep, that's it. Congratulations, Dad.
So to build this drawing, I'm just going to draw a triangle. I'm going to label it A, B, and C. And I'm just going to draw in everything that I know here. So A is 51 degrees. And B is 44.
C is 85.
C is, what is it?
85.
85, okay, so we could go find that, that's fine. And little c is 11.
Wait, how do we know that the angle C is around?
It looks like I know angle C and side C, so I know for sure that I'm going to use little c divided by sine of C equals, and then I can go find little a or little b, it doesn't matter. Let's go find little b. So little b divided by sine of b. Questions on why I'm using sine of C or sine of b or that piece of the law of sines? Alright, let's plug everything in. So I've got little c is 11 divided by the sine of 85 equals little b, that I don't know, I'm trying to figure out, divided by sine of 44. And then to solve this, I'm going to solve it just the same that I did before. Multiply by sine 44. multiply by sine 44. Real quick, I'm using the law of sines, and it's probably because I know I'm in the section of the law of sines, but what information was I given that told me that I was using the law of sines?
Angle, angle, side.
I was given angle, side, angle, right? So I'll try to write that a little neater. I was given angle, side, angle. That was my given information. So this was an angle, side, angle situation. That's why the law of sines works.
7.7.
7.7. So little b equals 7.7. That's fine. 7.7. Now, in the kind of name of time, I'm not going to go find little a, but it would be the same process. I'd use c over sine of c equals little a, little a over sine of a. So we're going to use this chart in any situation where there's side-side angle. That's why it's so important to first go figure out, is it side-side angle, angle-side angle, or whatever it is, okay? So let's go on to the next slide. Let's actually do an example. All right, so I just kind of recopied the chart up there so we could reference it.
All right.
So I'm going to draw the triangle first, A, B, C. All right, so here's triangle A, B,
Hey, this is angle side.
side-side angle.
Yeah, this is
You should put them in that order.
Okay, so angle A is 115. Little b is 11. Little c is, I don't know. I don't know little a. Oh, no, I do know little a, I'm sorry. Little a is 20. I should go, now is this an acute angle that I have been given or an obtuse angle? Obtuse! It's obtuse, it's 115. So right then, I'm going to eliminate the top row. I don't care about the top row. And actually, this not possible box, forget that too.
Yeah, screw it.
From here, everything, I'm going to approach it the same way. I'm going to go, I'm going to try and find one of the angles. I'm going to find angle B or C. B comes before C in the alphabet, so I'm going to go find angle B first. But it doesn't matter. So I'm going to use the law of sine just like I normally would. And remember, here's what we're kind of hoping for. If it's obtuse, either we're going to throw an error, or we're going to get a crazy summation of angles, or it's going to work great.
Let's hope for an error.
So let's see what happens. When I plug everything in, I'm going to use the law of sines without rewriting the equation. So I'm going to take 20 divided by sine of 115 equals 11 divided by the sine of b. So I'm going to take and multiply sine of 115 times 11 and times sine of b times 20. And we'll kind of rewrite everything here. So I get 11 sine of b. Yep. 115, thank you. Equals 20 sine of b. 20. And put that mess in your calculator. Alright, so what do you get when you do 11 times sine 115 divided by 20? Sine of b equals what? Was it? 0.5?
Do you believe her answer?
Take the inverse sine of both sides. So I'm going to get the inverse sine of 0.5 equals b. Make sure your calculator is in degrees. What do you get for b?
I got 30.
30 exactly.
Hey, good job.
30 exactly.
No. Yeah. 30.
I did the first step and I didn't get an error or angles that add up to greater than 180, right? 115 plus 130 is 145. Perfect. That means it can't be this box. I must be in this situation. If I'm in this situation, I can keep going. I can go find side C now. Or excuse me, I can go find angle C and then side C and finish solving this using the law of sines.
Just keep going.
Alright, so I'm not going to take the time to finish it because we're in a situation just like the previous examples. It's a triangle with one solution. Use the law of sines. Have fun. Okay?
Hold up.
A, B, C.
Yes, that's
And I'm given 51 degrees. And little a is 3.5, and b is 5.
Right.
That's been normal.
All right, so this looks like I've got,
Is that 3.5?
yes, 3.5, yeah.
And a half.
Okay. So it looks like I've got side angle.
Oh, done.
Okay. So now I notice that my angle is acute. So I am looking in the acute row now. I do not care about the obtuse row at all. All right, so I'm looking in the acute row. Once I've established that, I'm trying to figure out, or I'm going to approach it just like I would a lost signs problem from earlier. Okay, so here we go. Let's set it up. I'm going to take the sine, I'm going to take 3.5 divided by sine of 51. Notice that's little a over sine of big A. And set that equal to 5 divided by the sine of big B. Okay?
Right, big.
So one way to approach these problems is, instead of cross multiplying, is to flip both sides. Flip this side and flip this side. That is an absolutely okay algebraic move to make. And rewrite it as sine of 51 divided by 3.5 equal to sine of B divided by 5. It's very similar to those first examples we did, where all I have to do is multiply both sides by 5, and I can plug that in my calculator and go nuts. So I get sine of B, knock it off. Sine of B equals whatever that value is. What do you get for that value? 5 times sine 51 divided by 3.5.
Let's knock it off.
Here, and you get 1.11. And then to get B by itself, we said take B, and that's equal to the inverse sine of 1.1. And what happens when you put that in your calculator? There's an error. There is an error. This does not work. Okay? So what I would do at that point, as soon as your calculator throws an error, you know that you are in this column right here, in the no solution square. So I would write no solution, and then I would stop. First thing I'm going to do is draw the triangle. I realize that it's not obtuse. I'm going to cross off the bottom column because I don't care about that. Excuse me. I know that I'm dealing in the top column. And then I look at this, and I notice this, that the side opposite, 13 right here, is less than the side adjacent. So that tells me that it can't be one solution. I can eliminate the one solution situation. But just like the last example, it could be two solutions or it could be no solutions. I just got to kind of crash into it and see what happens. Okay? So here we go. I'm going to go through this pretty quick because we've done a million of them. In fact, I'm just going to do this. Sine of 40 divided by 13 equals sine of B divided by 16. That's okay, I just kind of saved the flip step. B is 16. Multiply both sides by 16.
How did you flip them over?
Because it's easier to solve. 16s go away. I get sine of B equals, I don't know, what is that mess?
16 sine times 40, 13.
B is 52.2 degrees. I'm going to write that into my triangle here. 52.2 degrees. And then what must my other angle be if that's 52.2?
87.8.
108 something, I think.
Yeah. Listen to the dumb kid. That's the right answer.